Nice. Okay. Welcome everyone to my first ever talk at the. Yes, I know. Louder. Okay. Welcome everyone to my first ever Flutter talk at the meetup. So today I'll be introducing you to game development with Flame, which is a game engine inside Flutter. All right. Let's start with some questions. Who plays games here? Raise your hand. Wow. Okay. Well, I expected the same thing. Do you have any game development familiarity? Have you touched game dev in the past? If you did, raise your hand, please. 2, 3, 5. Okay, maybe 7. Cool, okay. Do you know Unreal, Unity, sort of? Okay, the same people. Cool, that's fine, because today's not about that. Yes, even though we're here at the Unity office. So about me, my name is Song. Here's my LinkedIn, yeah. So I'm currently a data scientist at Outlier. Previously, I was a teacher at Vanier College. I taught Flutter. Yeah, that's what I taught over there. And I am also a game developer hobbyist. So I will share the slides later. So that's the link to my portfolio. And currently, I'm also building a startup. So today's the talk will be about some game development basics and how Flame fits within Flutter. We will also go over quickly how to import art assets, how to play with controls, do some physics and collisions, and finally, what's the point of doing Flame in Flutter if you don't use Flutter? So let's try some Flutter with Flame. So let's start with some basics. You might know this already if you have just done some games in the past. So there's a concept called the 3 C's of game development. Character, the first C. So what does your game model look like? If it's 2D or 2D with physics, then Flame can support that. But if it's 3D, then unfortunately Flame, the game engine, is not ready for that yet. Though there is an imitation for 3D at this link here. It is not 3D, like the engine is not 3D, but they made it look like 3D. So you can trick the eye with some 2D physics. The second C is controls. So how intensive are the player controls in your game? Are they minimal, just clicking around? Clicking around is not even minimal. It's just the bare bones. Or minimal, so you have like a few keyboards, like maybe WASD and a space. Or are they intensive? So intensive is when you have something more appropriate for game controllers. And Flame is best for the first 2 cases. So if it's just clicking around or some basic keyboards, then yeah. But if it's Overwatch level or like StarCraft, no, unfortunately. Finally, the third C is camera. So since Flame is mostly 2D, then if you have a static 2D camera, that's fine. Moving 2D camera, that's also fine. But 3D perspective camera, then that's a problem. So in Flame, the world is treated as an infinite 2D plane. Now, how does Flame fit within Flutter? This is how they decided to develop the package. So this is Flutter. It's based on the Dart language. And everything in Flutter is a widget. So a widget is like a component in React. It's an abstract concept that means something. And widgets are organized in a tree. In a tree. So how does Flame add into this? Flame will add this extra widget called the game widget. The game widget can be treated like a Flutter widget, except that it cannot have any Flutter widgets as a child of the game widget. And okay, there's a star. We'll come back to that at the very end. So here's our first code snippet. This is how you initialize Flame within Flutter. This is Dart, the programming language. I assume that you have imported the Flame package in your pubspec YAML. So then this is your main method in your main file. You will have the game widget. And as a generic, you have your Flame game instance. Then you have this factory method that it's like boilerplate. So importing art assets. First, to add art assets to your Flutter Flame project, you can do it the same way you do in Flutter, and that is to put it in the assets folder. And in your pub/spec YAML, you would expose this asset path, assets images by default. This is the path that the Flame uses to search for images in your project. So in this talk, we're going to use the example of a game that I didn't make it like from zero, but I followed it. Amber Quest. So here's how you would organize your files. Pretty simple. Just put them inside the assets folder, images, and then all your PNGs. And up there you can see what the assets look like. It's a bunch of sprites. We'll be doing a pixel game. Yeah, so let's see the game in action. All right. Oh my God, it's like tiny, even on my screen. It's fine, run and debug. So you will see right away that there is some limitations. Okay, so you see that there's a, what is this, like a content overflow. So by default, Flame is not responsive. It's a game. So you would have to like full screen this. But the Flutter UI is responsive. The game is not. And then refresh. And now it's good. So I'll just click play. So this is the game that I'm going to talk about today. It's a simple platformer. You play as this fireball, and the map is procedurally generated. It sounds fancy, but it's just it's a random selection of pre-made map sections. Okay, now let's die. Good. So you see the game over is working. I was playing. It's not a video. Okay, trust me, huh? Good, let's close this. And yeah, you see the buffer overflow error message is printed into the console. Now back to the slideshow. All right, so here's how you could, it's one way to do it. Import your images into your app, your game. So you have this onload method that is exposed by the Flame game like base class. It's like a parent class that you have to inherit, or in this case, extend inside Dart to say that you have a game. And I'm not sure if you know what is async and await, but like the reason why it's async is because images are big and it takes time. So in order to not block everything while you're loading, we're using async. So by default, Flame will load all of these images into a cache so that the next time you need to like summon this image into your game, it won't take the entire journey into the disk and fetch the RAM node. It wouldn't need to do that. All right, yeah, so this finger is pointing at the Flame game instance. Flame requires you to have this in order to have a game. All right, so after loading your images, you need to like introduce your camera. So the camera is like an instance that is part of the Flame game, a parent class. So to load the camera, you just add one line into your like an onload method. So camera viewfinder, anchor, and you would say that the camera is always anchored to the top left. So anchoring is similar to what happens in Unity. Like Unity also has anchors, except that in Unity, you use your mouse to click the anchor in the inspector. In Flame, you have to write it out in code. Okay, so this is how you would load a sprite animation to your specific like class. What we did earlier is just to warm up the RAM. Now you actually use the RAM. So you have this Ember player class that I made. It will be extending the sprite animation component. And that's what the sprite looks like. It's a sequence of 4 images, and it will be looping this forever and ever. So here you would say game images from cache. Cache is what we had loaded previously. So we had the Ember PNG. Now we will declare that this PNG is a sprite animation. So sprite animation data sequence, we have 4 sprites. Each sprite takes 0.12 seconds. to loop. And now the texture size here is 16. So texture size is the size of your PNG. And yeah, sprite animation. Oh, so texture size is the size of your PNG. But up there you see super in the constructor super size, vector2.all. That's the size you see in the game. So that's the size for your 2D world. This one is your disk image size for the file on your disk image. All right. So adding to the world, that was just loading, setting up a player class to actually make them appear in your world. You will have to use this add method that is part of the Flame game. So add is like, in Unity, this is like components. In Unity, you have the script components that you add to your game objects. While in Flame, you have this just add. And then you say, well, add like a certain component that I declared earlier. And this component here is your sprite animation. So add this. The world in Flame is a 2D coordinate. So the origin by default is on the top left. Going right is positive x. Going down is positive y. So yeah, I know it's strange. You'll get used to it. And then the canvas size will tell you at this point of your execution, what is the size of your game. So earlier we saw that if I refresh the game suddenly fits again. That's because the canvas size is only like accessed during this time. All right, yeah, Amber. Don't know how much Dart you know, but like in Dart, if you have an underscore, then it means it's private. There's no public private. Underscore means private, no underscore means public. Okay, cool. Now let's go into the controls. Yeah, so Flame uses a concept called mixins. So here you have a code snippet that uses the mixin functionality inside Dart. So what is a mixin? A mixin is like an implemented interface with properties. Okay, it's not just methods, it's also with properties. It's like inheritance, but you don't actually extend or inherit anything. So as such, you can have as many mixins as you want. And as a result, mixins do not make anything polymorphic. There's no polymorphism when you have mixins. So this makes it more, versatile. More versatile. So here we have the has keyboard handler components. So this mixin is added to your Flame game. And usually you only have one Flame game in your Flutter Flame project. So it will say that in your Flame project, the keyboard will be used. Then later, in your Flame components somewhere, you will have the keyboard handler, and that is the mixin that will allow you to respond to keyboard events. So here's the Ember.dart, so Ember player script again. We see a second method called onKeyEvent that is available after the keyboard handler has been whiffed. There's no verb for mixins, like inherit a class with a mixin. Yeah. Or maybe mixed a mixin. Exactly. What? Mixed with? Yeah. Oh, yeah, that's what it, okay. Well, I just learned something today. So mixed with a keyboard handler. Here's the finger. Yeah. So in Flame, you have this. It's like in Unity, the old Unity input system. You have a logical keyboard key. So this is a enum. It's a gigantic enum with all the possible keys you can have on your keyboard. And you would say, should the keys pressed, which this is a function argument, contain some keyboard keys, then in this case, do something. So in my case, I decided to change the value of this vector. Well, it's not even a vector, it's just a scalar, but it represents the horizontal direction. Should the keys be pressed arrow right, then we have a positive number, which means we are moving in the positive x direction. If it's the other keys moving to the left, then we will have -1. So this is what the question marks are doing. So how do we actually use this captured data? Perform the move. So to make Ember move, it is similar to Unity. You have this update method that is available to every sprite animation component. So in Unity, every game object has like an update method. It's a similar thing here. The update method is called every single frame in your game. And that's why you would need to use Flame. If you have a game that doesn't require a game loop, that like a recurrent tick, every single frame I have to do something, then maybe you don't need Flame after all. If you need to do something, then that's what Flame is good at. So in this update method, we will change the velocity. So velocity here is it's like a class field that I declared in the constructor. So the velocity.x is equal to the horizontal direction you have captured with your keys times a move speed constant. This is something you have to decide when you play your game, because who knows how fast you want it to be, right? So this is something you play around and be like, okay, maybe I need more, maybe I need less. Then you have your position. It's like a property. This one is inherited. So the moment you change the position in this method, it will like trigger an entire series of callbacks inside Flame. So here it's plus equals your velocity times the delta time. So how much time has passed in between the frames. Super.update is something you always need to do to wrap things up. Yeah, so that's what. I forgot I had these emojis. Sorry. Okay, yeah, that's what I did. Okay, so physics and collisions. Flame is kind of a simple game engine, so it doesn't have any physics by default. You would have to do it yourself. So by default, there's no physics. You will have to do it yourself. But it does have like an ecosystem of bridge packages. Forge 2D, it is not just a Flame thing. It's something that was invented like a while ago, but it was ported to Dart and now ported back into a Flame. So Forge 2D, should you require additional physics, then you would need to use this package. In my case, I only have gravity and simple collisions, so I didn't need that. I did my physics myself. So let's see the physics. Okay, before that, we need to talk about collision mixins. So here I have the same Flame game, except that I don't show all the mixins I have. I only show the one that I'm talking about. So in reality, there's like 5, 6 mixins, like whiff. So hitboxes. Do you know what is a hitbox? Yes? No? Okay. So a hitbox is something that you would add to your game, so to make it like respond to being touched or something. So if you just have an image, it's just pixels. In the eye of the there's no eye. But in the eye of the Flame engine, it's just a bunch of pixels. Like, what am I doing with this? If you add a hitbox, then it says, okay, then maybe if I touch this thing, something is about to happen. So Flame has hitboxes that you can add, and they come in various shapes. You would take the one that is the most closely related to your animation component, to your sprite animation. And it also has a collision matrix. It's much simpler than what you would find in Unity because it only has 2 choices, active and passive. So by selecting your collision matrix value, you would say, like, maybe I just want to collide with these kinds of hitboxes, not everything. So then to introduce a collision, you have this mixin that you add to your Flame game, has collision detection. And then down into your game, for your individual components, you have the collision callback mixin. So this is what the collisions look like, and this is what you will have to do if you don't have any physics prepared for you. As you mix with the collision callbacks, then the onCollision method is available to you. You will be given a set of intersection points on the world and a position component of the thing that this current component has touched. So here I have some customly declared types. Ground block is what you see in the game, the ground. Platform block is the blocks that float in the air. If other is this or that, then you have to do a bunch of physics. I didn't show all the code, but it's calculating the normal. Like if you remember high school physics, calculating the normal, and then detecting how fast it is. If you touch it, then what are you doing? So in this case, we want the player to stop. So we will basically set the velocity to 0, but only the y component, not the x component. So am I going too fast? This is like the last section. Good? Okay. So let's go back to Flutter. So earlier I have said that no Flutter widgets can be a descendant of the game widget. It's not really true, but it's not really false either. So what does this exception mean? So Flutter widgets can be added to the game widget as an overlay. Overlaying is not really having a child. Okay? It's not like having a child in the tree. It's more like a sibling relationship. So overlays are used to like display UI. In the case of the game that I showed you, that would be the main menu button, the game over, not button, the main menu, and then the game over window. So this is the way that you would use to leverage Flutter's power inside Flame. Because otherwise, like, what's the point of using Flame if you don't have any access to Flutter? So here's how you would do some UI within Flame. This is the main menu. It looks like everything you would see inside Flutter. There's nothing special except for a reference to the Flame game. So Ember Quest game is a class that I declared that extends the Flame game. And down there inside the return widget tree, this is our widget tree, you would have the game, so game.overlays, remove main menu. What this does is that when you press the play button, then we would get rid of the main menu. And then you can play the game. So this is how you would interact with Flutter widgets inside Flame. Oh, yeah. Is there any questions before I conclude? No? Okay, I'll just do the conclusion. So what is Flame? Flame is used to build games for many platforms at once because it's inside Flutter. It is, however, used to only do simple games. So no 3D, no AAA. Okay, you cannot do try to do Overwatch inside. I mean, anything is possible if you really want to do it, but it's not easy, okay? You can try to port Overwatch into a Flame and use Flutter, but it's difficult. And because it's inside Flutter, you can use the Flutter UI. You know how UI is quite hard to do inside Unity. I know, is any Unity staff here today? That's fine. It's quite difficult. If you have Flutter, then it's more simplified, though you're not obligated to. So in the game that I showed, I had hearts and the score with the stars. That was not done with Flutter UI. You can do this with a like a Flame component too. You're not obligated to use that. And this is, I mean, there's no drag and drop GUI as you would see inside Unity inspectors. It depends on you. Like, do you like that or not? If you think having a Unity inspector messes up your scenes because, oh no, that person changed the number and then it's like everything changing around, then maybe that's a good thing to you. But if you want things to be easy to change without opening the code, then maybe that's a deal breaker for you. But like the advantage of not having a GUI like the Unity inspector is that you can always expect your code to like do what it's supposed to do, because there's nothing else to change the behavior outside of the code you have written. So here's the repository to the game that I showed today. Let's do it again. Yeah, I'll just play the game again, and then just wrap everything up. So I am building to JavaScript web. This is Chrome, the Chrome target. You are able to, if you want, to build this for mobile, for anything Flutter can touch. So you have to refresh because the Flame game is not responsive. Okay, there you go. I know the text is tiny. So the collision mechanics, if you touch this, then you can trigger the events that you want to. The blocks, the platform blocks will block velocity down, but it will not block velocity on left to right. The jump, if you have noticed, has a terminal velocity. It's something I decided to do. It is to prevent you from crashing down too fast. And then you can jump around. I know, it's like you're gliding. It's not fair. Oh, okay, the hitbox is a bit larger than I thought. So you cannot you cannot escape the water enemy by just going over the one block. Let me do it again. Okay. Well, yeah, that's the game that I made today. So let's go back to the presentation. Which one is it? Safari. Yeah. All right. Thanks. Thank you for listening.